Alright, so I will be demoing the solar tracking camera. So I'm going to start by just plugging this in. Alright, so as we can see, the lights inside on the Raspberry Pi have cut on, and we'll just give that a minute so it can zeroize the servos. And so when it zeroizes, it will take the rotational servo so that the zero position is aligned with this red tape, and this tilt servo will tilt to 90 degrees. So we'll just give that a second. Okay, so we can see that the red tape is aligned for the most part, and then the tilt is at 90 degrees. So now I'll come over here to this control panel, and I'll start by switching the servo on and then switching the video on. So we can see that the device starts to track the position of the sun, as we can see up there. And so as it's rotating right now, it's going to try to stabilize to get the correct position and hold it there. So it will just take a minute for it to finally stabilize. So the way this device is set up is so that the more the entire device spins, the less these actual rotational servo, or this rotational servo, will spin. Because if the entire thing is rotating as a payload, and the rotational servo starts to spin, then it just creates a lot more momentum, which makes the spinning problem worse. It is a little bit windy outside, which is why we do have some rotation going on. But in general, we do see it gravitating towards the position of where the sun is up here. And that's just because these photoresistors up top are getting the most amount of sunlight, and so that's where the rotational servo is trying to direct the camera. Alright, so I'm gonna go ahead and shut this off. So I'll start by flipping the servo switch down, which will lock the servos, and then I'll go ahead and cut the video off. So now we see the lights start to blink, which means that the video is being saved. And then once those LEDs cut off, then we know that the video has been completely saved.